Okay.
Yeah.
Okay, then hello everybody and welcome to my very first talk in this Mule Meetup group and my second talk overall in the Mule Meetup. The topic I'm going to discuss here is based on the question, what happens when Mule meets a TeraDeta? I guess this is a comparatively rare scene combination here. However, it offers a nice opportunity to discover the fast import approach, as Mule and TeraDeta share one common property, namely the possibility to use parallelism when importing data to a TeraDeta Vantage system. And so what exactly to consider for implementation is the key aspect I'm going to show you here within my talk. And before going into the details, let me give you some more information about myself. I've started working with Anypoint platform in 2018, so it means currently I have almost 3 years of practical experience with those products. I also hold a current Mulesoft developer certification level 1. And because I have started with Mule release 3, I also know what things can be done more efficient and even easier in Mule4 compared to Mule 3. My current focus lies on APIs running on premise and mainly interacting with TeraDeta Vantage. And for those of you who want to gain more insights about my projects I've worked on so far and myself, and you are welcome to check out my LinkedIn profile, which is shown below here, this link. All right. And now, okay, so much for myself. And let's start with our topic by taking a look at the whole scenario here. So our scenario consists of 3 main components. The first one is a source system delivering data, which is intended to be imported into a target table on a TeraDeta Vantage system, mainly by means of a Mule API. And as indicated by those arrows, this process is intended to be parallelized already when the Mule API starts its importing process. And for those of you who are not that familiar with TeraDeta Vantage, let me give you the key facts here, which are sufficient to focus on. TeraDeta Vantage is a massively parallel operating system, which is due to the fact that it has a shared nothing architecture, which means that the processes can perform the major part of their tasks in parallel and independently of one another, as they do not share any resources. In TeraDeta literature, it's commonly visualized with a scenario of a card deck and the task to find out how many aces the deck contains. And in order to find out, you might share this deck among your friends, and everyone has its own stack. And after counting the aces on its own, their own, you can consolidate the results in the last step here. Another one important aspect is that in TeraDeta Vantage, that every row which is going to be inserted into a table is assigned to a hash value, which also determines the place where the row is stored in the table. So this place of one of the logical units which can operate independently of one another. And with this aspect in mind, there's another important feature, namely the fact that the locking of a table can be done on even exactly this row hash level. This means you do not have to lock the whole table with every request, but on the row hash level. And this aspect enables you to parallelize the process and more simultaneous writing accesses to your target table. So if you haven't heard of TeraDeta Vantage before, just think of a classical database management system. This is sufficient for our session here. Okay, now that I have told you about the whole scenario. I'm going to continue now with the TeraDeta Vantage side that will show us what we have to take into account in order to parallelize and optimize the importing process. And as the next slide shows here, this is a matter of the way you design your target table. This is a common target table, including some TeraDeta specific aspects. And the first one we are going to look at is the attribute shown here, namely which to declare your table as a multi-set table. So multi-set, simply stated, means that the very same row might be stored multiple times in your table. This is not what we intend to. However, the important aspect is that when declaring as a table as multi-set, then the system knows that it does not have to perform any duplicate row checks when one or more new rows are inserted into the table. And this is the first step to speed up and optimize your importing process. The second one is similar to it, and this deals with the so-called primary index, which you can see here. If you have never heard about this before, you might have thought of the primary key because of the common keyword here, but let me tell you that a primary index is a completely different construct than a primary key, whereas the primary key relates to a column that uniquely identifies a row and can be considered as a logical construct. A primary index is more a physical construct, which refers to usually to the most common access path to the data. And as well as the primary key is always unique, you can also declare a primary index as unique, but this one is something you also should be omit here. For the same reason, when it's about declaring your table as a multi-set table, in order to avoid other duplicate checks, which will slow down your process here unnecessarily. So these two aspects are for speeding up general your process. And the third and last aspect, now we come to the parallelism. This is related to the columns that make up your primary index. So what does it mean? These columns are those ones who determine the row hash value which is generated from their values. And if you're familiar with row hash or with hash functions, then you know the better distributed the input values, the less hash collisions occur, and therefore the most parallel process can be achieved when choosing the columns. And as we take into account that one and the same row can be sent multiple times to your target table via the Mule API, we choose a combination here consisting of the item ID here, which is in that case the logical key of our row, and another value which is unique to the actual API call. So, and when choosing columns combining a logical key and a uniqueness value unique to the API call, then you will gain the minimum of hash collisions and therefore the maximum of parallelism when it's about processing these rows when getting written into your TeraDeta target table. So, and as this, the target table design is the only one aspect you have to pay attention to on side of TeraDeta, this also means that all other aspects related to parallelism is performed by TeraDeta Vantage on its own. Okay, so the next slide I'm going to show will switch over to the Mule side and show the components we are going to choose for Mule in order to parallelize the process on sides of Mule. So now we have them, and these are exactly two components which are both new since the Mule release 4. The first one we're going to take a look at here is on the right side, namely the parallel for each scope that will allow you to process a request to your database, in this case in parallel. And yeah, if you know this scope, it's a commonly used one, then you will know that it only, by default, it will only allow you to split your collection into single elements, which is the main difference to the classical for each scope that includes a parameter related to the batch size. But in Mule4, there is a way to overcome this limitation, namely by using the divide by operator, which is also a new one since data week 2. This one will allow you to split up your data collection, which is consisting here of 5 elements, into subsets of elements. So in that case, I have chosen 2 in order to, so that it fits to my slide. And then we see here my collection consisting of 5 rows is split up into subsets consisting of 2 elements each. And in that case, such an element is interpreted as a single element by the parallel for each scope, but in fact, it's a sub-collection. So, and then by combining those features, you are able to process your data collection in parallel and also segment it into an appropriate size. So, what this means and why is this interesting, we'll see on the next slide. If you come from Mule3, then you might remember that when you need such an approach, it's much more challenging, as the combination of segmenting and parallelizing can, as far as I know, only be achieved with a batch flow, and using a batch flow comes along with other issues such as handling asynchronous behavior and the fact that when starting a batch flow, other important parameters might be lost unless you make use of a message transformer, for instance. So simply stated, this is, in my opinion, a great example how much simplification has been achieved in the Mule release 4 compared to Mule release 3. All right. So now take a look at the so-called requests mode. So when now performing the request to your target database, in general, you have 3 options here. The first one is very simple and consists in performing a single statement for every single row here that can, in that case, also be processed in parallel. This one is the most simple, but also the least efficient way, as TeraDeta Vantage and even other databases systems can handle requests much more efficient when they are packed into multiple statements and therefore achieving less requests overall. However, we will see how it performs compared to the other. The second one is the so-called multi-statement requests, which means that you will pack several statements into one request. When dealing with TeraDeta Vantage, there is one key fact you have to keep in mind, namely, in order to create a multi-statement request, every statement has to begin in the very same line where the semicolon, which marks the end of the previous statement, is in. In that case, TeraDeta Vantage will automatically include the statement in the same request as the previous one, unless it will find a semicolon which is not followed by another statement in the very same line. So this might be a little bit unintuitive, because this is related to just to the way you to a layout your query is layouted, but that's the one and only aspect which decides about which statements are packed into a multi-statement request and which not. And when making use of this will already make a huge difference compared to the previous one. In that case, however, you have to keep in mind that in every iteration of your for each scope, you have to generate the SQL requests individually. As you can see here on the left side, the values are included also in a hard-coded manner in your statement. So, and last one is the prepared statement we're going to take a look at. The prepared statement, as you can see here, does not include any values that are going to change from statement to statement here, but they are represented by question marks. So this means that there's just one statement generated for all upcoming requests, which making it the most efficient way to perform an import process to a TeraDeta database. And in that case, in order to make use of the prepared statement, then you can make use of the bulk insert operator, which then will make use of this kind of statement. So, and what this means, we will see on the next slide that will show you some performance results. And before I'm going into the details, I would like you to take a little time and have a look at this table here showing the results. All right, okay. One thing to mention before is that these performance results are based on an express version of TeraDeta Vantage and release 16.20, which is available for free and for usage with a VMware tool. So for those of you who are interested in performing some performance tests and experiments on their own, then you have this opportunity just by downloading it from the from TeraDeta site, and with a VM tool, tool installation, and a JDBC driver include your Anypoint Studio, you can do the very same thing as I did comparatively easily. And the sample data set I've used for this performance results consisted in 5,000 rows, yielding the following results we can see here. Now, when we take a look first at the single statement request mode, I've also included a sequential approach, in that case using a for each scope in order to emphasize the difference a parallel for each scope makes. And now when we take a look at the first one, namely performing a single statement request mode in a sequential manner, then we see this is by far the slowest one, taking almost 5 minutes for a sample data set of 5,000 rows on this notebook here. And we can see that parallelizing the request already makes a considerable difference by reducing the time taken by approximately 2 minutes. And when we now take a look at the multi-statement version, starting with packing the request into 10 statements, then we can see also the difference parallel makes compared to the sequential. In that case, we gain a running time of approximately 35 seconds. And it also shows that the sequential version is even outperformed by the single statement when making use of the parallel version. This is, in my opinion, a great comparison that will show which difference the parallel version of the scope can make. And the multi-statement version also shows that you should not be too, let me say, economical when choosing an appropriate segment size, because in that case, a segment size of 100 statement will also speed up your process by gaining yielding approximately 3 minutes here for the sequential manner and 27 seconds for the parallel one. And when we now take a look at the prepared statement, we will see that this one is by far the most efficient, yielding already 37 seconds with just 10 statements per request and performing the request in a sequential manner. And to summarize, you can see all requests are below 1 minute, and here in the bottom right corner, the The best result by far is achieved by combining a prepared statement with a parallel for each scope and packing the requests into 100 statements per request, which is also the only one that will allow you in that case to reach a performance result below 10 seconds here. All right, now that we have seen this performance comparison and what difference the package size and this request mode and also the scope, the kind of for each scope makes, there is one specific thing I also want to mention before we switch over to my live demo, and this is about nullable fields. So if you have made your practical experience with nullable fields or null values in other contexts, such as in context of database systems, you might already know that null values can be tricky to handle, as in some contexts they have a really counterintuitive or showing a counterintuitive, unintuitive behavior. And in that case, it's we should pay attention to two aspects. The first one is that when you have to take into account null values, then you are strongly recommended to keeping your statements simple. That means do not make use of any function calls, such as here, in order to convert data value into a timestamp here or other transformation. Otherwise, you will quickly run into the situation that your JDBC driver will return the error message that null is not supported as a data value with this variant of the set object method. So this at least holds for the prepared statement approach, which is, as I already said, the most efficient one here. And the other one is related to so-called implicit null values. This means when a field in your payload that is optional is not even included by its name, then making it implicit null. Then when you want to make use of the prepared statement approach, then you will get the error message, which I also have included here, namely that you are referencing a parameter which was not supplied as an input parameter. So in that case, you are required to convert your null values into explicit null values, so that the field name is included in your payload, but showing an explicit null value. This can be achieved by mapping the fields to explicit values, and I recommend you doing this in the bulk insert step, which can be done in the general input parameter section, such that this redundant payload is only needed exactly at the moment when it's being processed here. So with those aspects in mind, you are well equipped to make use of the prepared statement approach, even when you have to take into account null values. So, and I want to finish my the theoretical part of my talk by giving you another slide showing all aspects at a glance. So to recall, the recommended target table design, which is related to TeraDeta Vantage, is to declare your table as a multiset one, and you're declaring your primary index as a non-unique one, consisting of the logical key of your data as well as a value which is unique to the actual API call. The Mule components included here are the divide by operator, the parallel for each scope, which both are new to Mule4, as well as the bulk insert. And when you have to deal with nullable fields, please keep in mind that you avoid function calls in your SQL statement, as well as implicit null values. This can be overcome by using a separate mapping step during your bulk insert. All right, so much for the theoretical part of my talk. Now, let me switch over to the announced live demonstration here.
Hi, I can see one question is there. So can you take this question before going to live demonstration?
Okay, you can still my my
Yes,
screen here.
yes,
Yeah.
I can see.
Okay. Okay, let me just take my TeraDeta Vantage Express installation here. Okay, it says that the system is commissioned, is great. So now let's take a look at my postman here. This is my endpoint that will perform the fast import approach. And as you can see here, I have prepared all those options, making up my performance results by URL, by query parameters here. And yeah, now before I'm going to start my Mule app, I would also like you to give a quick tour through my implementation. So of course, at the first step consists in storing all the query parameters into variables in order to make them less volatile here. The next step consists of creating a payload from my variable input. This can be done comparatively easily by means of data weave. So as you can see here, I have also included a case when my payload consists of some null values here. And after this sample data payload has been created, the next step now is to consist of dividing my payload by means of the already mentioned divide by operator, which is also can also be parameterized here, as you can see here. The only thing you have to keep in mind that you have to explicit import it from the module shown here, as the divide by operator is not included in the standard repository when operating in the data weave context. So, and after this, depending on my parameters, the appropriate path here is chosen, which can be a multi-statement, as you can see here. Oh, come on here. All right, yeah, this one is the part that is being chosen when I decide for the multi-statement. And as I mentioned in my theoretical part, you can see here, no matter when you make use of the for each or the parallel for each scope, every request has to be created individually. And this gives me another opportunity to show you another nice thing that is new to Mule4, namely the opportunity to export commonly used functions into modules and make them easily available in your whole application. In that case, it's about a function that is used for creating a multi-statement request. And as you can see here in my request, I'm going to perform an import from an own TeraDeta module I've created here. And in order to create a multi-statement request, I just have to call this function and passing the input parameters consisting of my payload to other variable values telling you in which for which target table this request is to be created, and here the so-called transaction ID, which is the uniqueness value for my API call, and my function here is stored into a separate data weave language file. So this one is an example for the data weave function that can be used in order to create a multi-statement request we have seen in quite an efficient way. All right. I have chosen the same approach for the SQL request, which also has been generated once before the for each or parallel for each scope is performed, namely one for the prepared statement. I've also made it easier for me by creating another function. In that case, okay, I have to pass the columns we are talking about here on my own, as it's not derived from the payload, and we've learned the payload might be incomplete when implicit null values are included. So, and when the import process has been finished, then we are going to confirm the success by showing, performing a select and showing all data that has been now imported into a table for this transaction. And in case of TeraDeta Vantage, we also are required to explicitly convert the payload into a JSON format in order to receive a valid output here. All right, so now it's time to run my configuration here, and while it's starting, you still have the opportunity to take a look here at the whole process. So, okay, why it's still starting here? Let me tell you that I prefer to start with this combination seen here, for the simple reason that, as you can see here, the other ones just take too long in order to be included here into my talk, and I prefer to go with you to this remaining 5 combinations here. And I'm also curious how long they would take compared to my actual tests. As you can see here, my resources are already heavily being used by you due to my online session here. So it's going to be interesting. So the first one is to perform the insert for the parallel version and the multi-statement at a segment size of 100 and a size of 5,000 rows. So give it a start here. So as the table shows, without my Mule meetup session, it took approximately 27 seconds. So I expect that this will take at least this time now here. So let me see if I can check here the progress by performing a select on my target table. Connecting here. So how many rows are there? Okay, we can see 1,680 so far. So it indeed takes considerably longer when there is a concurrency with the Mule meetup session here. So maybe I should have reduced my payload size a little bit, as this would also be show that the proportions match here. Mm-hmm. 3,096.3. So for those of you who haven't seen TeraDeta Vantage before, this is an opportunity to show you which option you have to take a look at your data while a writing access is in progress, namely to perform some kind of dirty read by downgrading your log from a read log to an access log. This means you take into account that the state you will get from the data is not a finalized one and might be rolled back due to a failed transaction here. Oh, so we see 2 minutes and 12 seconds. So this indicates how significantly this process has been slowed down by the concurrent session here. Okay, just let me continue I guess I'm going to reduce it a little bit to the half one and continue with the prepared statement and the 10 statements per request. So in that case, I have to modify my import operator to prepared. So let's see how long this takes here. Oh yeah, 100% CPU. Nice. So now the final result is supposed to be 7,500 rows. So 1,000 rows remaining. Now we have a time of approx of 37.5 seconds here. Oh, that's interesting. So this means this might allow us to conclude when doing this in parallel to a meetup session. Okay, it's being slowed down by the half. Okay, in that case, I guess we can continue with those sites and for the other ones. So let me see how it performs when, no, excuse me, I've already chosen here the parallel one. So in that case, let me just show you the remaining two here by modifying the size to 100 segments and doing it sequentially. So this is expected to be, okay, now we have just 8 seconds. This is interesting. And then, so let's switch over to the ultimate combination, namely the parallel version of the prepared statement and 100 rows per request. In that case, I like to return to my original size here, namely the 5,000 rows. Now we have 14 seconds. Okay, let's see how it will perform for 2,500. So I guess it's also taking a little bit longer. Okay, still this is the fastest one in that case, taking 6 seconds. And I also like to perform some more. And I wonder if anyone of you, I didn't now can tell me how many rows we have in total in my target table. So just solve it. I will solve it by taking a look at this. Okay, 20,000 rows here in total. And as we can see here in the previous result, we have also some null values here. All right. Yeah, now this completes also the live demo part of my talk. Now it's time to thank you all very much for your attention, and I'm looking forward to answering the questions you might have regarding my topic. Thank you very much.
Yeah, Lars, thanks. And I get one question is there in chat section. So can you take that question?
Yeah. So I stopped sharing my screen now.
So Lars, you can see that question. Dhananjay pushed. Yeah, one question from Dhananjay I can see there.
Let me see. Is there any concept of triggers in TeraDeta? And if yes, how much that may cause these states to change? I mean, roughly it would be proportional, would affect all scenarios by same magnitude irrespective of the approach. So in that case, my question would be, what kind of triggers do you mean? Do you mean the classical triggers that will react on an access to the table and performing a subsequent request, or is it about triggering the whole data import process here? So when it's about classical triggers, yeah, of course, triggers, TeraDeta supports classical table triggers as other database system, I guess, and there are also some practical issues you have to deal with, however, not in that context. This is more when you have, for example, stored procedures and operating in different session modes. In that case, it might concern you. But in other cases, I think there's nothing special about triggers in TeraDeta context here. But in general, I would not recommend placing triggers on the target table, as this will definitely slow down your import process and might also call rollbacks on the requests. Okay, the other one, will you share the code after the session? You mean the whole app code? I can do this, of course. I just need to know so where the code is commonly shared after such a session. Is there, as this is just my very first talk in this new Meetup group, is there a common place where where I can provide you with that?
Actually, for code, I think we can share on email. Actually, we can upload slide and video on this Meetup page only.
Maybe,
but I don't think we can share code. Okay, for code, actually, Sagar, you can provide your mail ID, and I will send you on mail, or we can upload on this Git server, and you can download from there.
All right, I'm going to inform you after this meetup which path I've chosen. So either I do it on my own.
Git server and, yeah, you can share on Git server, and you can provide me that link, so email. I can upload on which. Yeah.
Yeah, all right, that's fine with me.
Yeah, okay, thanks, Lars. So Karthik, so now you can start from your part.
Okay, sure. I'll share my screen.
Yes.
Okay, you're able to see my screen?
Yes, Karthik, we can see.
Okay. So, good day to everyone. So, the next topic, and first of all, thanks to Lars for explaining about the integration from Mulesoft with TeraDeta. It was really informative. So, the agenda of our next topic would be like, first, we would see a general introduction about me, and then we will see why is messaging required. Okay. Then we will see about the different types of messaging mechanisms, and then I'll show you a little bit demo on that JMS working of point-to-point way of messaging, and also the pub/sub way of messaging. Okay. So a little bit about me. This is my first Mulesoft meetup session with this group as well. So I did a very session long back, maybe years ago, like 3 years ago. So this is my next session. So I'm working with Ramco Systems as a solution architect, and we build logistics products mainly, which is warehouse managing systems and transport managing systems. And dealing with logistics, it has a lot of integrations involved, be it with order management system, with other ERP systems. So I've been morely working in the integration role. Okay. So the next question is like, why do we need messaging? So we have multiple ways of integration, right? Like you have you can connect with REST API, okay, and you can also connect other things through a file system, okay. So there are multiple things. So why do we exactly need a messaging way? Okay. So the reason would be like, let's consider a scenario, okay. So you have got 2 different applications, okay. So this is first application is a kind of an e-commerce application similar to your Amazon, Lazada, or Flipkart. Okay, so which is built in a very with a very good server configuration, and it is absolutely great in performance. Okay, so and you have another system which is a warehouse management system, because the way that e-commerce works is once an order is placed in your order management system, right, or your e-com platform, it is actually directed to the nearest warehouse from which the particular item can be picked and delivered. Okay, so let's assume in this case that the warehouse managing system is quite a bit, it's not that much performance oriented, and it is built to be to considering other parameters. Okay, so you need an integration between these two systems, which has two very different ways of working. One is high performance, one is low performance. Okay, let's consider. So if this is going to be integrated with the API, right, like what happens, APIs tend to work in a more synchronous way, correct, like REST APIs. Okay, so once an order comes into your platform, and if you're going to hit the APIs in the WMS platform, at a point of time, there is a possibility that the calls can entirely choke your WMS systems. It depends upon your architect, but I'm just saying for this, like for an sample scenario, it might choke. Okay, and if you are going to delay the message transfer from the e-commerce system to this WMS system and hold up all these messages in the e-commerce system, right, then what happens in that e-commerce systems, it might grow up the size of the messages, and eventually it might also make the e-commerce platform it to degrade the performance. There is a risk in that. Okay, so they thought like the synchronous ways are not actually suitable for all integrations. Okay, so we need to have a different way of integrating things. Okay, and this doesn't mean that REST is like message queue is better than REST APIs, or REST APIs is better than message queues and file integration. Nothing like that. It depends totally upon the scenario that we are working in. Okay, so what happens now in this kind of case, we will be having an intermediary one, which is the queues actually. Okay, so now what happens, the e-com messages, it can process like in a minute 5,000 messages. Okay, but the WM system, let's consider it can only process 100 messages. Okay, so even though there is a disparity, that you don't have to worry about this, because whatever messages has been processed, it can be queued up in the middle layer, which is a queue layer actually. Okay, so e-commerce doesn't have to really wait for the other system to be ready to take up these messages. They can just drop into the queue and they can do the other activities. The WMS system on the other part, they can process by picking one message each one at a time, and they can do the process. So this doesn't affect the core applications in any way, because all these things would be handled by the queue. Okay, so that is what this asynchronous way of messaging is suitable for some scenarios. Okay. Okay. The next key quality is assured delivery. Okay, I'll let you know some examples about this. So I'll give you an example, like when you make a money transfer, right? Like you request like from my account to another account. Okay, okay. So this is let's say there's an NEFT transfer. Okay, so what happens, and we should be very sure when we put some request for that, it should be executed by the system. Okay, it should not be lost in any way. Okay, queues have this property called persistence. Okay, which will make sure that the message definitely gets delivered to the end application. So even though your server gets rebooted or there is any issues, your message can still be persistent. I'll show you some examples around that in the live demo as well. Okay, so this again gives the strength, and it makes the system very resilient, actually resilient to failures. Okay, so we don't have to worry about the message getting lost. So it gives us more resilience. Okay, and the last thing is it is easily scalable as well. Okay. If your traffic is going to take a spike, let's say there is a sale that is going on in your e-commerce platform. Okay, and you're going to expect traffic which would be like 50 times X than your normal traffic, right? Okay, the easiest and the most simpler way to actually handle this is by scaling the application, scaling the message queues, which can easily actually be done actually. I'll show you some examples for this as well. So as I'm working in the logistic industry, we have been dealing with a lot of e-commerce customers. Okay, and the e-commerce customers, in some point or in some application integration, definitely there is a huge need of this queuing message. Okay, and next is chat application. Just think that I'm sending a chat or there is a person. I just want to send a message to the other person, but the other person is not readily online or available actually. So this message sits in the queue, and when the person actually sees the message, then it actually, the other party consumes the message. So till the message is being seen by the person, it still is in the queue. Okay, so it gives such kind of use cases are used in this messaging concept. Okay, next one is the money transfer request, which I told. Next comes the next two are the public the pub sub model. Okay. So some in this group might be a huge fan of cricket, correct? Like, and some might be a huge fan of football, and some might follow the stocks of certain companies. Okay, and so now what happened? There are so many vendors, or there are so many companies which gives channels like CrickBus, CrickInfo. They give the updates of the score, correct? So so if let's say that person 1 and 2, they are very interested in cricket, then they can subscribe to cricket as a topic. Okay, they can go into a site and they can say that I need newses for cricket. Okay. So what happens now? The person who produces the score lines, right? Okay, they will not individually send the message to the person 1 and person 2. Instead, they will publish a message saying that this is the topic for cricket, and automatically whoever has subscribed for this topic will be getting these messages. Theoretically, it might sound a little bit vague, but in the demo, I will surely show you how it works. Similarly, notifications of any sort. Okay, so one of the things commonly used is a stock market notification, because everyone wants to see when there is a price hike for this stock above a certain percentage or below a certain percentage. They need a notification, correct? So such kind of notification can be handled through the message queues. Okay. So there are a lot of queuing mechanism, but the main 3 things are the JMS, which is the Java messaging services, which we will be seeing in this session. Okay. So JMS is not a protocol. First, everyone should understand it's not a protocol. It's an API which came as a part of J2EE, okay, your Java Enterprise Edition. Okay, so but normally the protocol which is being used underneath is like a TCP actually. That's the connection that we will be using. Okay. So the next one, which has been popularly used currently, is the AMQP. Okay, Advanced Message Queuing Protocol. Okay, so this was developed by JP Morgan, or better known as JP Morgan Chase now. Okay, so back like in 2003, and this has been considered as one of the key protocols nowadays. And the last one is your message queuing telemetry transport. This is specifically designed for connection or integration between the IoT devices, because it's very lightweight, and if there is an IoT component which needs we need to calculate the speed of the a car, okay, or temperature of a fridge, okay, so they can't have a greater bandwidth. Even there is a low bandwidth and the size of the message is small, then MQTT is your go-to option, okay, of messaging. And I also suggest, like, if anyone has any questions, you can just drop into the chat and I will just reply on that. Okay, so there are 2 major message models which is supported by JMS. One is your point-to-point, and another one is your publish-subscribe. Okay, so the point-to-point is the one which I told about your chat applications, and the public subscribe is the cricket updates, the example which I gave. Okay, we'll see it in the live demo. Okay, so point-to-point, rather simple. There is a producer and there is a consumer, and if you drop a message to the queue, the consumer just consumes it directly. Okay. On the other hand, in the pub/sub model, there is a producer or a publisher who actually publishes a message with a topic, and whoever has subscribed for the topic will receive the message to them. Okay. So that's how the model works. Okay. So I'll just move on to the live demo so that you can understand all these concepts better. Okay. So first I have just created a HTTP listener component, okay, which URL as publish. Okay. So if you type in JMS, you can see that we have got different options over here. Okay. Okay. So before we see about this, first let me tell you about the just a minute. Okay, the message broker that we will be going to be use. So it is ActiveMQ, which is a part of your Apache open source project. Okay, so it's very simple. You can just go to ActiveMQ, okay, and you can download it from there. It's free to use. Okay, so there are two options actually. If you see, one is the 5 classic version and one is the next generation Artemis version. Okay, so for this demo, I have used the classic 5 version. The reason being is like because the support for Active5, right? It comes out of the box in the Anypoint Studio itself. Okay, still Anypoint Studio also supports the Artemis version, but it doesn't come out of the box. We just need to add some dependencies and for that to work. Okay. So the key difference is like the JMS, the current version that is running is 2.0, but predominantly many of the companies or many of the softwares are compliant with 1.1 actually. Okay, so the classic version supports 1.1, whereas the Artemis version supports 1.1 and 2.0. So actually that is a major difference which I see actually. Okay. So we will be using this 5 version for our sample. Okay. And it's very simple. You will be getting a file which you need to just unzip and just need to you can install it as a service actually. Okay, if you go just double click this, you can see that it will be getting installed as a service. Okay. So you can see that ActiveMQ is a service which is running. Okay, so once it is running, you can actually access the ActiveMQ console through this URL. Okay, this is a default URL. Okay, you can change it in the configuration file if you need it. Okay. Okay. Next, okay. Now we are going to what we will do is we will create some queues actually. Okay. So let's say we will create a queue called input. Okay. And we will also create a queue called output. Okay. Okay. So we have created a queue. So let's start with simple example like transferring from here to here. Then we can move on to the most other options that we have as well. Okay. Okay. So now if I go to my Anypoint Studio platform, first what I will do is like I'll publish a message. So what I'm going to do is I will have an API. So that API will call a service which is nothing but this service. Okay. So it will just post the message to a queue. Okay. So if you go to this publish component, you can see there's a connector component required. So we just need to provide the connection details of our MQ. So Anypoint Studio has this option wherein they have this Maven dependencies automatically downloaded. So you just have to choose this option. Okay, and you can see here the specification. So Mulesoft actually it supports all 3 and they are complement with 1.0.2, 1.1 and 2.0. So they are compliant with all the 3 versions of the JMS specifications. Okay, so we will be using our 1.1. And the username and password is admin Amir, and this is your default username and password for ActiveMQ. Okay. Then so this is a component like the broker URL which needs to be provided. Okay. So what is a broker URL is nothing but if you see we would in core it is actually going to use your TCP connections. Okay. So if you go to configurations, you can see that there is a file called ActiveMQ. Okay. And if you open it, you can see that the TCP connection, right? The TCP connection is listening on 61616. So this is the port which is listening on. So we just need to provide this as a broker URL in our component over here. So let's do TCP / localhost 61616. Okay. So better to test everything once you get the component created. Okay. Test is successful. Okay. Okay. So connection parameter is successful. Okay. So now I want to just publish this in a queue called input. Okay. Input. And you can see that the destination has two different types. One is a queue and one is a topic. So let's first see about the queue version of it. Okay. Let the payload be here. The other options, we will be seeing that in a minute. Okay. Okay, fine. So let me deploy this particular thing. Meanwhile, hope I had it as publish. Okay, it's deployed. Okay, so this is a sample JSON message. So first, let me try to post this. Okay, so it's just returning back because I have not set any response back. Okay, so if you go to the refresh, you can see that the input queue has a message. Okay, make very sure because act like any queuing platform is case sensitive, because I can even create another like input queue with capital letters because it's case sensitive actually. So the common mistake, like mostly like which I have done in the past, is like I could have not provided the correct cases actually. So make sure that you just look it for that. Okay. So now let me go to the message. Okay. Go into the message. So you can see that there's a message and you can see the priority is 4. Okay. I'll explain this about later. So you can see that we have got a message. This is our message which we have sent from our HTTP component. Okay. And that's a default property. And you can see the persistence as non-persistent. Okay. Okay. And a few other things as well. Now, what we will do is, now let's try to have some properties changed over here and reflect how it is being showcased here. Okay. Okay. So I can see here, we have got a property to make it as persistent. Okay. By default, it is non-persistent. Okay. But you can make this property as yes so that it becomes persistent. I'll show this at the end of this particular transaction. Next, you have got a priority. Okay, so you can set the priorities to messages. So by default, 4 is the priority which is set. Okay, but whatever you have like 5 to 9, right? They are considered as a high priority messages. If you have a message of priority 9, then that will get the precedence or that will be processed first. Okay, that's how priorities work. A simple example is like there's a news network. Okay, they publish news regularly, but there's a flash news or there is a emergency news which needs to be reached first. Okay, then they can actually have the priority as 9 and they can send it actually. Okay? So I'll just put some example. Let me put the like a priority 7. Okay, and I'll save this. Okay, so that it gets redeployed. Okay, and now just for the sake of the message to for you to understand that there is a change in the message. Okay, so if I go to the component, okay, and if I refresh, I can see I can get another message, and you can see there is a second message which is of priority 7. Okay, so you can decide depending upon your application, the message that you're going to work in, you can set the correct priority that you want in. Okay, so that is the importance of this priority field. Okay, next there is a time to live. Okay, see, this is like again kind of a thing. You say that how much time this message needs to be in this queue, because after a while this message can be like not valid. One example is your OTP. Let's say OTP. Okay, so you send an OTP and it's only valid for 30 seconds or 1 minute. Post that, it's not useful. Okay, so we can provide a parameter to time to live. So it be like it would be in the queue for certain time. If no consumers are consuming it, it will automatically be deleted from the queue. Okay, so let me give this time as 15 seconds actually. Okay, 15 seconds. I'll put. Okay. Let me wait to get this redeployed. Okay, fine. and I can put some other. Okay. Now if I go to queues, I can see that 6 is the one. Okay, so you can see that there is an expiration time which is there. I'll just copy it. Okay, this expiration time is nothing but they call it as the like system time actually, or the Unix time, I guess. Unix time. Okay. So you can see that actually this is the format which is available in this queue actually. Okay, so this gives like after this particular time. So this is nothing but your current date and time with the seconds, right, is converted into this format. So it will expire after this time is what it means. Okay, I think it's post 15 seconds. So let me check. So you can see that the particular message we send is automatically cleared from the queue because we set a time to live. So it has passed that time. So it is out of the queue. Okay. So now going back to the other options. Okay. So I'll just remove this so that it doesn't hinder us. Okay. And okay. And you can see that there is a delivery delay feature actually. This is only supported in like JMS 2.0, not in 1.1. So we can't showcase it here. So it is like you can delay the delivery of the messages to your consumer. Okay. So this is a new feature which comes in JMS 2.0. Okay. Not in the other versions. Okay. Now let's talk about the persistence. Okay. So I told the two messages which are available in our queues, right? You can see that the both are like not persistent. This is also not persistent and this is also not persistent. So what does it mean? Okay. So now let me stop my active MQ instance, or let's assume that your server is shut down or something happened to your server. Okay. So I'm just simulating. Okay. So now your MQ portal will be no more accessible. Okay. It's no more accessible because I have stopped the service. Okay. Now let me try to start it again. Okay, I started it again, and if I go to the queues, right, I could see that the input queue has 0 messages, and both of my messages has lost actually. Okay, so this is not good if you are dealing with some high priority or some financial transactions or messages of like huge importance. Okay, if there is a message which is of not much importance, then you can make it as a like a non-persistent. But what if you need it to be a one which should actually be disaster proof? Then is where you actually select this persistent delivery, which is yes actually. Okay, so now if I not sure if it got redeployed. So now let me try to just so I'll go to the queue, refresh it. I can see one message. Okay, and if you can see that the persistent now is persistent. Okay, so now let's replicate this scenario. Now let's say that your server is down. I'll again stop the service actually. Okay, I'm stopping the service. So my MQ instance is like no more properly running. Okay, so now let me again start this session. Okay, so I'll start this session again. Okay, so now if I go to the queues, I can see that the message didn't get lost. Actually, it is there actually. So this is the importance of making a message persistent. And it is not always that you need to make all the messages as like persistent. It depends upon the message that you deal with, whether it is an invoice, which may be of higher importance, or it can be just a cricket score update, which is of not much importance. So it depends, because what happens is like when you make it as persistent, the message, a copy of this message gets into one of the files over here. Okay, so it will take up your disk space as well. So we need to like see the scenario wherein we can have this as persistent and non-persistent. It's not like we need to make everything as persistence. It differs case to case. Okay, I think I could see some errors. Okay, because it was not able to connect, I guess. Okay, let's stop. Okay, so next thing, like what we can see is.
I have one question.
Yes,
Yeah.
yes.
Actually, here I can see like correlation ID, okay, and we are getting
Yes.
that correlation ID by default. But for example, we have requirement like front end will call our API, and whatever transaction ID they are passing, we want to use that transaction ID as a correlation ID. So, can we achieve this kind of thing here?
Now, actually, currently, if you see the correlation ID, right? Like you have an option to send only choose these parameters actually. So, and to be honest, like I have not used anything out of the thing, but I can understand your query. But there's a different way that we can handle. I'll let you know about that. Okay. For that, we have an option over here. I'll cover that in the session, which comes as a part of this published consumer.
Yeah. Okay.
I'll definitely.
Yeah. Ashok also has one query. Can you, if
yes,
possible, you can see that. So
okay,
let me read that question. So for persistent, expiry time work or not? If we are
it will work actually, because time to live is like you are giving it persistent. You should see from a disaster perspective actually. Okay, for a persistent message, if you give it as a time to live as 5 minutes, okay, and in 5 minutes if your system is up and running, it will actually clear it from the queue. Okay, persistent is only required when there is a disaster happening. You got the point, right? Like if you're not, I can explain it.
Yeah, so he's replying yes.
Okay, fine. So definitely, if time to live, it will be there and it will be cleared from the queue. Okay, fine. So now the next option is like what is like. So now let's say again the same thing. Order management system, e-commerce system is posting into a queue. Okay, so there is an warehouse management system which will pick the queue and it will check in the warehouse whether the item is available. System, yes or no, like whether it got it or not. Okay, so it is a asynchronous model, but there's a request reply element kind of thing like involved as well. Okay, so in that case is where we need to tell the other application, like because the application which is publishing is your e-commerce application, it should say to the WMS application, when you confirm it, can you please reply me back? Okay, so that is what this reply to queue is there. Okay, I'll show you, because if you see here, the reply to is null actually. Okay, this is just an header component. What we are trying to tell is, I will just drop a message in the input queue, but once you have something, once you have processed the message, can you please put that into another queue? That is the value that will be posted here. This is an information only. Okay, just understand, it's not a working, it's an information that you pass on to the other system. So I can say that, can you please put it into the output queue? Okay, so if I do this, just give me a moment, it is getting deployed. Okay, fine. Okay, so what I'll do is, now I'll send a message. Okay, now if I go to the queues, okay, and I can see there's a reply to component which is available, which has been. So now the other application which will be consuming this message, right, will know that, okay, once I process this, I need to send you some reply into this queue. Okay, so they know that this is being done. So that is the property of reply to comes into picture now. Okay, so I think we have seen most of the options which we have in the published thing. Okay, we will move on to the next one, which is a consume thing. Okay, so now let's start consuming it. Okay. So I'll just type in JMS. Consuming is nothing but you are going to pick it from a queue, and or you are going to process it, take a message from a queue. Publishing it is you are dropping from a queue. Consuming is you are just going to take it from a queue. Okay. So you need to have a source component here. Okay. So I'll give it as a scheduler for now. Scheduler, and let the scheduler run like every one second. Okay, and we go to this consume component. So in this example, what we are going to trying to do is like, let's try to pull this message from this input queue to this output queue. That's it. Like it will just, or let's do a simpler thing. Let it consume from this input queue and just print the value as over here. Huh? We'll put a logger component. Okay. Logger component. We will just print the payload. The payload, and so destination is nothing but the queue where in which you need to fetch the messages from. So we have messages in our queue called input. So this is our thing. And we should provide the JMS component details. Okay, that's a consumer type. By default it will take it as a queue, but we can queue it as a queue consumer. Okay, there's a topic consumer and a queue consumer, so we will be using a queue consumer because we are fetching from a queue. Okay. I'll tell you about these parameters later. For now, let me see whether it is deployed. Oh, there is an error. Okay. Okay. You can see that it has read from that queue and it has printed it actually. You can see that, right? Like the messages, 2 messages. Okay. But you can also see that I'm getting a timeout error like for every 1 second. The reason being is when you use a scheduler, right? What happens like scheduler, it is polling for every 1 second, and it is one second, and it is checking this queue. If there is no message available, right, then it will just throw this error continuously of timeout. Okay, so there is a way that you can. There are 2 ways. Okay, I will tell you the least preferred way. Next, I will tell the best way. Okay, so the way that you can prevent is there is a max wait time. Okay, so by default, actually, it waits for 10 seconds for any messages to be pulled from here. Okay. So now, if I give this as -1, right? So what happens? You should not be getting any error for the timeout because it will check for any messages in this queue continuously. Okay, it will be continuously polling this queue for any messages. Okay, just by providing this parameter. Okay, so I just provided this parameter. Okay, and it got deployed. So let me try to. Okay, there is no messages. Okay, so now let me try to just post another message. Let me give this as. Okay. Okay. So I should see that the message, because we had a printer logger component, but there is no timeout that you would be getting. Okay, so just by providing a -1, you are indefinitely waiting for that. Okay, but this is not a preferred way. Okay, the preferred way is in JMS itself. There is a connector called onNewMessage. Better to use that. Okay, so what I'll do is I will just remove this component. Okay, or I'll remove this as a whole actually. Good thing. Okay, and if I use onNewMessage, right? So what happens is like whenever there is a new message, it will actually pick. Okay, so it is suggested that we should be using, rather than a scheduler, right? Using a scheduler and scheduling it for 1 second or every 10 seconds, use a onNewMessage. So whenever there's a new message coming in, it will poll and it will actually process that message. Okay. So I'll give a similar example, okay. And just to showcase you how this works. Okay, consumer type is queue. Okay, 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 okay. So in this, you can see that there is a component called number of consumers. Okay, see, this is nothing but this increases your number of parallel threads or the number of parallel connections. Okay, So what happens if you have a queue in which a lot of messages, high traffic messages are going to come into that queue? If you want to process more, you can just change the number. Like if you say 8, then at the same point of time, 8 different threads will be formed and it will be polling that queue. Okay. So it's not like one thread is like, rather than one thread like trying to get that message and process it, 8 different threads will be like deployed and it will do. So it's just a simple number change which will actually help us to get parallel processing. Okay. So for this, I will have it as 1, just for easier sake. Okay. But there's a ready-made option. That's what easier ready-made option which is available. Okay. So okay. So if I can put a logger component as well. Similarly only, I'm just trying to explain the same process in a different way. That's it. Let me just be. So it got deployed. There is some errors. Okay, it got deployed. So you can see that when there was immediately when there was a new message, actually we couldn't even see that the message being over here. Okay. So when it was there, immediately it went into this queue. It actually, what our flow did was it published into this queue. And once the message was there, it took it and it actually printed our message. So better to use on new message component if you want to continuously poll a queue for messages. Okay. And there are cases where schedulers are used because there would be one large message coming in at the end of the day kind of thing. By that time, it is not wise to use an on new message because continuously this process will be polling that queue. By the time you can have a scheduler kind of components. Okay. Now let us see about the other components as well. Okay. I'll go in depth with the the publish consume next. Okay. Okay. So now what happened was, like, even though the asynchronous pattern was good or it was nice, there was a need to have a way of simulating a synchronous transfer using these queues actually. Okay. And that is what made birth to this particular publish consume. Okay. I'll provide you a detail. Okay. So let's say that I have an API. Okay. I will publish it and I need a synchronous response back. So if you can see currently, it is not the way because we are using a asynchronous model of working. But with this publish consume model, you can actually simulate a synchronous way of working. And I'll show you how that is done. Okay. So let's create two queues, actually different queues now. Okay. Let's create a queue called request. Okay. And another queue called response. So now what will happen is, like, I will make a flow in which I will be calling a HTTP listener. Okay. And it will publish into a queue called request. Okay. And we will simulate application working kind of thing. So from the request message, we will be just consuming the message, or we should consume a message, and when there is a response posted in the queue, right? Okay, then synchronously you will get a response for this API. Let me show you that in the working so that is more understandable. Okay. So your destination would be request. So when you publish, this is the same component itself. You have options for both publish and consume. Okay. 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 So this is your destination. Okay. So we should be fetching it from request queue. And there was one query actually in this session, correct? You want to have a request reply kind of pattern. So this is where the message ID comes into play. Okay. I'm not sure about the correlation ID. So you can actually play around with this message ID actually. You can have the message ID which is being populated from the source application, and you can actually have it over here. Okay. But for this thing, we will use the correlation ID. Okay. And we'll select this as always. So let's always send the correlation ID. Okay. JMS type. Okay. Okay, let's make it as persistent. Okay. And okay. Okay, maximum time. actually I'm using -1, but this is strictly not allowed, because if you have it as -1, then our API call will indefinitely wait for the response from the particular application. It will be just waiting. There's no timeout. You can have a particular timeout of 60 or 120 seconds. Just for this demonstration, first I will make it as an indefinite wait so that you understand the concept of how it works. Okay. So now what happened is, like, let me go through this again. Publish, consume. Okay. So you can see that there's a reply to component. Okay. So let's give this as a response. Huh? So it will just wait for a response in this queue. Okay. That is the way it is going to work. Okay. 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 I think it is deployed. Okay. So now let me trigger this, and you can see that this request to be like on forever because I used the -1 as a wait time. Okay. And if you go to the console, you can see there is one request message in this request queue. Okay. And you can see that there's a unique correlation ID. Okay. And if you see, the thing is still waiting. So what is happening is, what we have said is, like, until we have a message in the queue called response with this correlation ID, this will be waiting for it. Okay. So now what we do is, we will send a message to, like, I'm just simulating the way how an application will work. Obviously what should happen is, like, it should take the message from the request queue and it should process, and then it should drop into the response queue. Okay. But to do some constraints, let me try to manually mark it. Huh? So I have copied the correlation ID because the correlation ID should be same. Then only it knows that for this request is what we are getting this response. We will say that processed successfully. Huh? We will say this. Okay. And if I send this message to this queue, right? The moment I send, you can see that I will get this particular response back. So instead of -1, if I give it as 120 seconds, means then it actually resembles an API model, right? A synchronous API model. Okay. So this is how the request, the publish consume model works. So using queues, which is basically a synchronous way of working, we are actually modeled it in a way that it can work as a synchronous, like a pattern. Okay. So that is the one for this request. Sorry, publish consume. Okay. Other parameters is like okay. So in consume itself, let me show you some more examples. Okay. So okay, I'll put on new message. Okay, on new message. Okay. Q and JMS. Okay, let me put it as input, right? Like okay, output. That's a message in output. Okay, put it as output. Okay, and you can see here, like, we have got something called okay. Okay, you can see that there is something called selectors actually. Okay, even from the same queue, you can actually write some conditions wherein you want to select a particular message and you need to process them. Okay, so let me go to this queue and you can see that the priority is 4 actually. So we will only consume messages with priority 4. Let's try that. Before that, we'll go and we'll have other messages with some other priorities as well. Huh? So we will set this priority as 2 and we will say test message. Huh? And we'll also send another message with priority 5 and we will say test. So there are 3 messages in this queue, and if you can see that one is 2, one is 5, and one is 4. Okay, so let's say that we wanted to only consume with the priority 5. Okay, then in this case you can use this selectors component. Okay, so these are keywords. You can actually like the headers, the keyword headers, you can actually find it from the documentation. Like for this, your selector is like JMS priority. Okay, so what did I mention? 8, sorry, 5. Okay, let me change it to 5. So, okay, there is an error. I don't know which is causing it. Oh, sorry, I didn't put any process file. I'll put a logger. And let it actually. Okay. Put this the queue. Okay, let me trigger this. Okay, sorry, I did it wrong. Okay, let me do one thing. I'll just remove this component. Queue consumer, okay. JMS priority. Good. Okay, looks good. Let's try to run it. So only message is checking for the output queue. Okay. Sorry. Okay, I'm not sure. Let me try to post another message. I hope it is. Let's put it as 5. Okay. Queue on the message. Okay, I'm not sure why it is not working, but let me go past this, okay, so that I can cover the topics part as well. Maybe by the end of this, we can see this as well. Okay, now we have seen a way that a direct point-to-point connection happens, right? Like let's quickly see how a pub/sub model will work. Okay, you publish it to your topic and how that works. Okay, let me put the same example and the HTTPS component. Okay, let me publish it to a component. Okay, and let me have, we should select this as a topic. Okay, so before that, let's create a topic over in MQ as well. Okay. So I'll create a topic called cricket or football. Anything is fine. So we have created a topic called football. Okay, so we will be publishing with a topic called football. Okay, so that is what we are doing over here. Okay, so now let's have on new message component, and here we should be looking for a topic consumer, and the topic that I want to be subscribed is football. Okay, so once it comes, let us again let me create like we are going to simulate a user. Let's say there is an user called football 1, like a user called football 1. Like just imagine that these are like two different like persons who are interested in getting the feeds for football. So whenever I topic a score line, these two people needs to be notified. Okay. So we will actually, so what happens is when there is a new topic being published, right? So it will not just listen for football, and we need to provide who would be the subscribers. So we are just mocking a application which will be like working as a possible subscribers. Okay. Okay. So we would be posting that to this queue called footballer one. Okay. So what happens whenever there is a topic being on football being placed, right? So this guy will get a message in his queue. Okay. Similarly, the same component, let me try to do it for another person. Let JMS football. And select our JMS component, and also the second one is football 2. Okay. So okay, so we have got our components right, I believe. Okay, so let me say that full time. Okay. Okay, I'll just check out the, oh, it was not running, sorry. Just run this Mule application. Okay, there is some issues. Let us check what it is. Okay, maybe I have not provided the, okay, the connection details were not provided properly. This is something which happens because that is not prompted as mandatory. So we might tend to miss out this connection details. Should open now. Okay, we got a new error. Let me check that. Okay. I forgot to say something else. So if you need to access the broker, right, to consider to have it access to a topic, you need to have this particular thing enabled as well. So sorry about that. I didn't know that. So you need to have that particular dependency deployed as well. So hopefully it is fine now, I guess. Let me try to stop and start the application again. Yes. Okay. 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 I think I got the issue. Just Just give me a minute. Just figure it out. Okay, I just used another component which I created earlier. I'm not sure about what was our issue with that component, but I'll definitely get you an insight of that, like what happened with that. But yeah, this is the same component. If I just show you, it got deployed. The same thing, like wherein I had a listener which is listening on a different port, actually 8088. So I'll be using that, and the particular topic or the URL will be topic actually. And what happened is, like, I publish it, and there is a new message component which will actually look for that particular topic, and it will just post into that queue. So it got deployed. So let me try to change this and send a request. So a request has been sent. Okay, is there an issue? Let me go to the topic. So you can see that there is 2 messages which has been queued into this topic. Let me go to this component. Okay. Okay, I found out what the issue is. Okay, in that on new, okay, I'll explain you what I did wrong. Okay, so that you will also understand that. Okay. So what I did is, like, when we fire an API, actually it will publish it to a topic with the topic called football actually. Okay. So now we have an on new message component. This on new message component should actually look for a topic. Okay. So I didn't like provide my topic, I guess, over that. That was the issue. Okay. So as this was case sensitive, it was seeing for small football as a topic. Whenever there is a topic with this football being published, right, it will actually publish into this football too. And the same thing I did it for the other thing as well. Like, it will check for a topic for football, and if there is any message is the topic football, it will actually publish to football 1 queue as well, 1 and 2. Okay. So now I have changed it. So let me try to again check that actually. First we will purge okay, we will try to again post this. Okay. Okay, now you can see that both these persons have got on message actually. Okay, so if you go to the message, you can see both of them have got the message for the full-time update. Like, there is a in both. So this is how a sample publish subscribe model works. Okay, mostly used in like mass alerts or what way notification which needs to reach a lot of people. Okay, so in an organization, what happens is, like, if someone needs let's say the data of the speed of a vehicle, something like that, right? So there will be a producer which would be just publishing a message as speed actually. Okay, so whichever application, there can be like 10 application which needs this data, they just need to subscribe for this particular topic and they will get a message for them. Okay, so that's it about for the JMS one. Any questions?
Yeah, Karthik, I have one question. For example, if
Yes.
subscriber is down at that time. Okay. So
Yes.
what will happen with that message? That subscriber will lose that message, or we can handle this?
You can actually have you can handle that as well. Actually, there is a possibility for that as well. Okay, so if you go to the topic, right? Okay, you can handle that as well by doing a persistent delivery. Actually,
Okay. Okay.
okay. I'll show you some demos, or I'll send you some files around that. Actually, how you can implement that.
Okay. Yeah, got it.
But possible, yeah.
Okay. We have couple of questions in chat window, so you can take.
Yes. I'll just check that. So, question is, does the spec guarantee delivery to reply to, or it is fire and forget? Reply to, when I Kirtidara, the one that I told, right?
Yeah.
If you're just putting that in the reply to, the first thing is just like an information only.
Okay.
Okay, it's a fire and forget. But if you use this, what to say, publish consume, right? Then you would be actually waiting for the message. It's like a reply response model.
Okay. That answers. Thanks.
Thanks. Do you have any JMS property to mention number of messages to fetch at a particular point of time? JMS property, I showed you the number of consumers, right? It's just a consumers actually. But is your question that I want to only fetch 10 messages from the queue? Correct? That is your question, I guess. Or
That's
50
right.
messages from the queue.
Exactly. That's right, Karthik. So the use case could be an on-demand JMS where the client wants to fetch only particular number of messages from the queue. Yeah, whenever they need. Yeah.
Okay, a batching kind of thing, right? Like, yeah, it is definitely doable, but there is no ready-made property for that, at least in our connectors, Subramaniam.
Got it. Yeah. Just want to check that.
But we can do that. I'll just check that. But yeah, we have did it in a different way, but not ready-madely as a property.
Okay, yeah, sure, Karthik. Because the selector also does the same thing. Basically, it will group the messages with the priority and fetch, right? So that's why I was checking.
You can. That's what you can play around with some properties. Let's say priority 8. I mean, I couldn't unfortunately show you that, but I'll check what went wrong in that. So you can fetch some priority messages alone. That's what. But the number of messages, let me check. As far as I know, there's let me check on that. I'll post it in any group or some WhatsApp, whatever you have. I'll just post that.
Actually, WhatsApp group and even Telegram group, so you can join and you can.
Yeah, that would be
Sure.
Thank you.
Okay, thanks. Consume versus subscriber. Ashok, can you elaborate that so that I can explain you? Okay, I'll move on to the next one. In PubSub scenario, is there a good way to let consumers subscribe and unsubscribe for topic dynamically without having? Yeah, actually, Melissa, what I showed you is just a demonstration actually. In the real world application, actually, we simulated only. So if you have a Java program, right, you can just use this JMS applications and you can subscribe to your topic actually. Okay. So I just showed you with the Mule application to demonstrate as a stub actually. So any person can quickly subscribe or unsubscribe to a topic dynamically actually. It happens. It happens in all real-time news update scenarios. Like today I'm interested in sports and politics. Tomorrow I might be interested in photography as well. So the moment that I do that, what happens is that it gets added into the particular subscribers list. It depends on the application which is consuming this particular topics, because obviously Mule themselves we will not have consume the topics, so it would be like an other application, a Java application or a different sort of application. Okay, I hope that answers. If not, let me know. I can provide you with some examples as well. Is there any limitations for subscribers, if any? how to handle it. Okay, actually, we can't have any control. Like there's no limitation as such, Nagaraju. Like you can have as many subscribers as you want, but a thing is like the main purpose. Like if you need to have each and every subscriber to definitely to get this message right, then we might have some other strategic like way of platforms as well. Okay, here it is more aligned to a fire and forget model, kind of like you say something and core is interested in the topic, they get it. And here the main like the way that the MQ wants to work is like in a fire and forget model, or the PubSub model. Okay, the publisher never cares who their subscribers are. Okay, the subscriber can be Ravi, it can be Karthik. So the person who is actually publishing, they don't care about the person who is consuming. So that is more centric. And if we want to control the subscribers as well, then I think this is not a suitable platform, Nagaraju. Okay, difference between consumer and subscribers. Like I would say like, okay, in more terms, it's just an analogy actually. Okay. Subscribers, when we are dealing with PubSub model, right? Like when there is a public, like a topic published and there are so many people who needs that message, which is that topic, we call it as subscribers. Okay. Obviously, they are also consuming the message, but when there is an like a there's a point-to-point application which directly consumes from the message queue, right? We call it as consumers. But this is just an analogy just to make a difference. But you can, subscriber is actually a consumer too in general terms. But we use this term subscribers when it is fetched from topics and consumers when it is directly from a queues. I hope that answers, Ashok. Thanks. Okay.
Okay, thanks, Karthik. I think Lars is facing some problem while. Okay, he connected now. I think. Okay. So now we'll go with Kahoot and we'll play one trivia quiz. So 3 lucky winner will get chance to win this training voucher. Okay. And after that, if anyone has any other further doubt, then you can ask. Okay. Otherwise, we'll end our session. And meanwhile, let me send you our group link so you can join. Just give me 1 minute. If anyone interested, then you can join this group. So you will get latest update about Hong Kong Meetup. So we have both Telegram and WhatsApp group. Okay, and after this session, when I will upload video and all, then I will notify in this group. Okay, now you can stop sharing, Karthik. So I will say, okay, you already stopped now.